Hello, and I'm talking about sequences today, and in previous videos we've looked at various things about sequences, and if we've just been looking at sequences written out by some wordy rule, maybe the term-to-term rule, or in this case position-to-term rules, so add 4 to the position, or multiply the position by 5, then subtract 1, well, these are all very well and good, we can do this. Add 4 to the position. Well, for the first term, the position is 1, so that's going to be 5. And for the second term, the position is 2, so add 4 to that is 6. And you can work out the sequence. Multiply the position by 5, subtract 1. So for the first term, it's position of 1 times 5, take 1 is 4. 2 times 5 is 10, take 1 is 9. 3 times 5, 15, take 1, 14, and so on and so forth. So you've been doing that no problems, I hope anyway. So why have I entitled this Sequences in Algebra? Well, it's just to show you that we can write these things out much more succinctly using a bit of algebra, sort of the language of mathematics, so we don't have all these wordy things happening like this. Okay, so if you're asked to do that, if you're asked to sort of rewrite this as algebra, then the position gets the letter n. Now, you could use anything, really. The whole point about a letter is it represents an unknown, so the n is the unknown position, so that you can then say, oh, well, now it's 7, or now it's 12. N is the unknown position yet, for you to decide what position you want. And we could use any letter, but as convention, we sometimes use certain letters for certain things, and we always do, we always use that letter everywhere you go. And for sequences, n is what we use. You might have heard of the nth term rule, and that's something we'll talk about in another video in more detail. And that n is exactly what we're talking about here. It's just the letter standing in for the value of the position, so where you are in the sequence. So we can rewrite these in algebra by saying, okay, add 4 to the position. Well, if the position is n, and we add 4 to that, well, we can just write that algebraically as n plus 4. Multiply the position by 5, so if the position is n and we times it by 5, we put a 5 in front. I'd rather you didn't do, try again, n times 5. That just doesn't look as tidy as 5n. Remember, if you're doing timesing, put the number in front, and then you can just type it like that. And then subtract 1, we'll then just take away 1. Next example, multiply the position by itself. Well, the position is n, and if you multiply something by itself, it's squared. And that's it, n squared. Divide the position by 2, so the position n divided by 2, nice and straightforward. Multiply the position by 3, so 3n, and subtract the result from 20. So that means 20 take away 3n. We're subtracting this from 20. That word from, it's in italics because it makes the difference. Otherwise, if it was multiply position and subtract 20, that is obviously very different from 20 minus 3n. If it's the other way around, subtraction is not commutative. You can't switch it around like that and get the same answer. Okay, so those are just rewriting the words, doing the words but with the algebra with this letter n. And actually that doesn't come up so much as you get to higher exams like GCSE. What you get more of is having to work out what that sequence, what that position to term rule would be from a sequence, but that's another video. And the other thing is that they might give you a bit of algebra and ask you to work out a number of terms. So they often say things like work out the first 5 terms, or maybe just work out the first term and the 7th term. We'll do that. Okay, and so remember the letter n is the position. So for the first term n is 1, for the 7th term n is 7. So for the first term we do 3 times 1, because it's the first term, plus 1. 3 times 1 is 3, plus 1 is 4. And for the 7th term, 3 times 7, 21, plus 1, 22. For this one, we're just going to substitute 1 in as n again. So 1 squared plus 1 is 2. 7 squared plus 1 is 50. And exactly the same thing here. Just each time you just substitute in what term do you want. I want the first term, so substitute in a 1. I want the 7th term, substitute in a 7, and etc, etc. So 1 plus 3 is 4. 4 fours are 16. and 7 plus 3 is 10, times 4 is 40. So hopefully you can see it's that actually using these nth term rules isn't a difficulty at all. It's just a case of thinking, what term do I want? Is it the first, the second, the third? Which one do I want? And putting the number from that ordinal, they're called, so from that sort of where are you, that first, second, third, take that number, put it in as n, and then do the maths. Okay, if you're not very good at that, then your calculator can do that. If you've got this calculates dead easy, you can go 3x instead of n, 3x plus 1, and press the calc button. It'll say, well, what is x? You can say, oh, it's 1 for the first term, and it'll tell you the answer is 4, and then you can press calc again, and it'll say, what is it? You say, put in 7 this time, and you can get the answer out, 22. If you haven't got this calculator with that calc function, you can still do it, just a little bit more clunky. You'd have to say 7 store as x, and then you type in 3x plus 1, and it will work it out. Let's change it to a different answer. Okay, let's just type it in afresh. 3x plus 1, and it's now using the stored value of 7. And if you want to do it again, you'd have to say 1 store as x, and then 3x plus 1, now it equals 4, because it's using that new stored value of x. So there you are. That's how to rewrite wordy questions in algebra. And if you've got algebra questions, it's just substitution to put in the value of n for the position that you want to get out the value of the term that you want. If I've confused you, if you have any questions, then pop those in the comments below. Otherwise, cheerio.